1.5.1 Using gravity in the uniform acceleration equations. When an object is falling under the influence of gravity, it actually speeds up a little bit each second. In fact, it speeds up about 10 meters per second each second. This is because gravity is a type of acceleration. Gravity causes acceleration. On the surface of the Earth, the acceleration due to gravity is the same everywhere on Earth, or that's what scientists accept. If you were on the surface of another planet, you would find a different acceleration due to gravity, depending on that planet's mass. The acceleration due to gravity on Earth is given by the symbol small g, not to be confused with big G, which we're going to use later on. And it equals 9.81. This is the value we'll use in Physics 20. G equals 9.81, and since it's acceleration, meters per second squared, the direction is down. This is really important. Since G is always down, G is always used as a negative in calculations. G is a form of negative acceleration. And here's an example that will show this. A rock is dropped from a 5.1 meter high bridge. How long does it take to fall? Well, to start with, our acceleration is g, which is 9.81 negative because it's down meters per second squared. Vi is 0 meters per second squared, or meters per second. The displacement is 5.1 meters, and it falls down. We have to be really careful to notice that this direction is actually down. It goes from a higher location to a lower one. When an object falls down, its displacement from start to finish is down. This means that it has a negative displacement. So displacement in this case is negative 5.1 meters. We're looking for time. Time is question mark. The formula that includes displacement, initial velocity, time, and acceleration is displacement equals VIT plus 1/2 AT squared. Now, normally we can't solve this one for t. Normally, this formula is much too hard to rearrange for t. This is because t is squared and not squared both at the same time in the equation. But in the case when Vi equals 0, it becomes much easier. This is because Vi is 0, therefore Vi times t also equals 0. And we can cross the VIT term completely out of the equation. And the equation just turns into d equals 1/2 AT squared. This can be rearranged for t. Rearranging this for t, we get t equals the square root of 2d over A. So now let's plug our numbers in and get an answer for t. T equals the square root of 2d over A equals the square root of 2 times negative 5.1 meters divided by negative 9.81 meters per second squared. And it's a good thing we put the negative in the 5.1 because now we have no negative under our square root and we get a time of 1.0 seconds. Our second example is a little bit trickier because we are going to have an initial velocity, but still have to use the same formula. A rock is tossed up at 10 meters per second from a window 25 meters from the ground. How long does it take to reach the ground? Sometimes when dealing with problems, it's best to start by drawing a picture to help visualize all the variables in the situation. So here's the window, 25 meters from the ground. This means overall, the distance that's going to fall from start to finish, it is a displacement of 25 meters. Even though the ball goes up and back down, the up and down part of the journey doesn't matter to the displacement. The initial velocity of 10 meters per second up is our initial velocity, and we're looking for time. VI is 10 meters per second up. We write this as positive 10 meters per second. The acceleration is gravity, is 9.81 meters per second squared down, which is negative 9.81 meters per second squared. The displacement, and here's the important bit, is 25 meters down. It goes 25 meters from start to finish. Because it's down, this is negative 25 meters. The negative is so important to this calculation. Time is question mark. And normally we'd write VF is don't care. But in this case, do we? Maybe finding VF might be useful. Let's look at our formula. The formula we would normally use, this formula that doesn't include VF, or VF is our don't care variable, is D equals VIT plus 1/2 AT squared. But this formula is really hard to rearrange for t. If VI is not equal to 0, remember in the last example VI was 0 and that's why we were able to use it. So instead, we have to go about it another route. There's a sneakier way we can get at this time. It becomes a two-step problem. In the first step, instead of finding t, we're going to look for VF. And in the second step, we're going to use VF to find t. In an easier equation. So let's start with step 1, finding VF. VF squared equals VI squared plus 2AD. So VF equals plus or minus square root VI squared plus 2AD. We have to be careful with this plus or minus. Normally we ignore it, but VF is a vector, so the negative actually does matter. At the end, the rock is falling down. Just before it hits the ground, VF, it's falling down. So that means we want to use the negative because of the down. This is going to be important in our calculations and it will change the numbers. VF equals negative square root VI squared plus 2AD. VF equals negative square root positive 10 squared plus 2 times negative 9.81 times negative 25. The negative part of the 9.81 cancels out the negative part of the 25, and it actually changes what our calculation's result would be. Negative 24.300200576 meters per second is VF. Don't round these intermediate answers. If you round too early, you're going to introduce error into your calculation. Save rounding for the very last. Now that we have VF, we can move on to step 2. Step 2 is finding t. Now we have VI as 10 meters per second. Acceleration is negative 9.81 meters per second squared. VF is equal to negative 24.300200576 meters per second. T equals question mark. Much easier formula that involves all these variables is A equals VF minus VI over T. Rearranging this one for T is much easier. T equals VF minus VI over A. So T equals negative 24.300200576 minus positive 10 divided by acceleration, which is negative 9.81. This gives us a time equal to 3.496453 ... seconds. And now we can round because we're on our last step and we need 2 significant digits. So this gives us time equal to 3.5 seconds.